Let's add a crafting block entity to our Minecraft mod. Even more topics available in the 121 Minecraft modding courses, now with energy and fluid handling for block entities next to many other awesome topics. Alright, we find this back in Taylor once more, and in this tutorial we'll be adding a crafting block entity to our Minecraft mod. Now, at the very beginning over here, before you start this like 50-minute journey, as you can clearly see, the length of this tutorial is quite extensive. The idea here is that, of course, we've seen the block entity before with our pedestal over here. But now we want to create a block entity that can also craft something similar to, let's say, a furnace. So you can think of this as a custom furnace. It's not exactly a custom furnace, but that's the idea. In this tutorial, we're going to basically implement it all, but we're going to have it hard-coded so that it can only, let's say, do one recipe, and then we're going to deal with the recipe in the next tutorial and things like that, because it's already long enough, basically. But yeah, with a block entity, it's always sort of a run around because we have to, well, revisit each class anyway, so we're going to start with the custom block class. So this is going to be in the block custom package. We're going to right-click new Java class called the growth chamber block, in this case. There we go. And it looks kind of like this. I also highly recommend you go down to the description below. There is a GitHub repository link with all of the code available to you. I highly recommend you take a look at it because we will be copying over a couple of things, actually quite a few things, simply because a lot of this stuff, number one, you've seen hopefully in the pedestal block entity tutorial already. And then when it comes to the, the logic and the other stuff, that is when we are going to do like a deep dive. So the block class will extend from the base entity block class. We're going to hover over this to implement the two methods we need. Hover over this again, create constructor matching super, where we're going to change this to public over here in this case. Now, the first thing we need is the map codec. Very straightforward. It is just a public static final map codec of growth chamber block over here, equal to the simple codec, and then just using the growth chamber : new. Very straightforward, and we can simply return this in the codec method. Nothing to worry about. The new block entity, well, because we don't have that yet, we're going to make a deliberate error so we don't forget to actually add this later. And then you also, which is very important, have to override the getRenderShape method, where we will pass in RenderShape.model. Extremely important, otherwise your custom block entity block will be invisible, which is not something you usually want. So that is very important. The next step is two different methods that, once again, I will copy over. Like I said, in the description below, you find everything that you're going to need for this. And the idea is that this is going to be the onRemove method, as well as the interaction method, the useItemOn method. Now, we're going to get a couple of errors over here because the growth chamber block entity class is not yet added. But not to worry about it. That's totally fine. We're going to add this, of course, and then these errors will go away. The idea in the onRemove method is that basically when this particular block breaks, I want all of the contents of the inventory of the block of the growth chamber block entity to also drop. That is what we're doing in the onRemove method, while in the useItemOn method, this is the right-clicking method, basically saying that if we right-click this particular block, I want to open a menu, specifically the menu that is associated with the growth chamber block entity, and that's basically all that is happening here. So those are these two methods. And then lastly, we wanted to override the getTicker method. Now this one is a little bit different. Once again, we're going to copy that one over, but it's not too crazy. So you can just override this, and you can see the first step here is actually, we're going to say if it's the clever client side, then we're just going to return a null. That's totally fine, and that is okay. That then makes it so that our tick method will only ever be called on the server. Very important here. And then here, after the if statement, we're going to return the createTickerHelper method, passing in the pBlock entity from the parameter over here, passing in the registered block entity, which of course right now doesn't exist yet. We have to still create this. This is what I'm saying. We have to revisit classes a couple of times because that's just the way that it goes. And then here we have this like level block pause block state growth chamber block entity construction that points to the growth chamber block entity. Note, by the way, this is the one given right here, not the block entity type, but this one. And then we're calling the tick method on it, passing in the level, the block pause, and the block state. And this tick method, this is going to be our best friend. You're going to see we are going to be able to, well, basically have a method, right, the tick method, that gets called once every tick. So that would be 20 times a second inside of our custom block entity class. And that will allow us to, progress, to craft things, to do all sorts of crazy things. We'll see that in a bit. But yeah, that is the idea. And that is the block class in this instance for the time being done. let's register it in the mod blocks class, of course. And this one, super freaking simple. We can simply duplicate the pedestal. Now, always when you duplicate something, make sure to double and triple check everything. Of course, changing the name right here and changing the name right here. And this is super important if you actually do copy things over, changing the class over here. This is a new growth chamber block. And we don't even need the no occlusion in this case. So it's just a normal block like this. And while we're at it, let's add it to the creative mode tab, because that is a thing that I might forget if I don't do it right now. That's basically the idea. And then we have the block over here added. Awesome. So then we can actually create the block entity class already, and adding, well, in this case, we're going to add all of the stuff that we've seen with the previous pedestal block entity already. There's a couple of new things as well, but we'll see those in a second. So first of all, in the entity custom package, we're going to right click new Java class called the growth chamber block entity. There we go. And this one will extend from the block entity class, and it will implement the menu provider interface. This is both what we've seen in the pedestal block entity before, so this shouldn't be anything new. We're going to implement the methods that it needs. We're going to hover over again, create constructor matching super. And here, of course, we need to first of all change the type, so that we're going to, basically delete the type of the parameter, which of course leads us to an issue right here, right? We're going to get an error right here. However, we can very easily fix this by actually registering our block entity. And that's exactly what we're going to do. So we're then going to go to the mod block entities class over here and simply register it. Once again, I'm going to duplicate this. However, because we already have this registered. However, here, once again, it is super important to go through each individual step. This is a block entity type, this time of the growth chamber block entity. The name here is going to be the growth underscore chamber underscore BE. The name is changed, growth underscore chamber underscore BE. This is now a growth chamber block entity, and super important, modblocks.growth chamber. Very easy to make a typo over here if you duplicate stuff. Listen, I like duplicating, I like copying over stuff, absolutely, but it is very easy to make a mistake over here. So do keep that in mind, that you have to always be vigilant about each individual step over here. But then we can close the modblocks or the modblock entities class and simply go modblockentities.growthchamberbe.get. And there we go. Now, in theory, the errors in the block entity class are done, but of course, the contents are not, because we want to do some cool things. So the first thing is we also want an inventory. However, it's going to work a little bit different. So once again, we're going to copy this one over. It's going to be an item handler, this time a public final item handler and item stack handler of size 2 in this case, because we're going to have an input slot and an output slot. For this, what I highly recommend you do, this is super, this is going to be so much better or so much easier. Do this. The item stack handler, obviously we can access this by saying item handler get stack in slot 0. That would give us the, let's say, the input slot in this case. And then if we pass in a 1, it would give us the output slot. But having these input slot and output slot written there, it makes it so much easier to read and know what is going on, except instead of having, get stack in slot 0, get stack in slot 1, get stack in slot 2, especially if you have like 8 different slots. I highly recommend you always label them like this, basically, and then always use these static integers, these integers, just to access it. It's super important just to be able to read it easier. Then we're going to need a private lazy optional. This is going to be a lazy optional of item handler, and this is going to be our lazy item handler. Item handler, there we go, equal to a lazy optional dot empty, actually. There we go. This is going to be something that we're going to need for a couple of other things over here. And then finally, what we also are going to need is a container data. We're going to need progress and max progress. I will explain this as well. So the container data will allow us to synchronize certain variables from the server to the client, which is very important because let's say the progress and the max progress over here, this would be the crafting progress, right? How far along is my crafting progress? And I want to show this to the client. So anyone who has the GUI open, I want to show the arrow being rendered as the progress progresses, so to speak, right? And that will all be done via this container data. Now, it's going to look kind of strange, but we're going to see. So inside of the constructor, we're going to add the following thing. Data is equal to new container data. And then this is an anonymous class, which has to override the get method, the set method, and the get count method. Now, the get count method is just 2 because the 2 variables that we wanted to basically sort of synchronize is the progress and the max progress. And you can see we then have a get and a set method over here, which simply points to the progress and the max progress over here, and here it sets these values. So that's the idea, and the container data, like I said, is super important so that everything gets synchronized properly. Very, very important. Now, when we're on the topic of synchronization, let's just add the two syncing methods at the very bottom over here. This is the getUpdateTag method as well as the getUpdatePacket method. Both of those, like I have previously said in the pedestal block entity tutorial, basically always look the same. They are just there so that everything synchronizes properly, and we're going to have no issues with any sort of desync. Now, for the lazy optional, we need a couple more things, and that is the onLoad method, as well as the invalidateCaps method. The onLoad method is simply going to be the lazy item handler equal to a lazy optional.of, and then a supplier of our item handler. So this is going to be basically our inventory. And then in the invalidateCaps method, simply lazy item handler.invalidate. Nothing too crazy, nothing too insane in this case. Furthermore, we have to drop our contents when we break this block, and that happens with the drops method. This drops method is exactly the same drops method that we have here. It is one-to-one the same, so this should be nothing crazy. Once again here, it simply drops the contents of the inventory of this block entity, right? That's basically all it does, and that's the whole mystery of it. And finally, we want to save and load data. Now, when I say save and load data, I of course mean the inventory, for example, right? We somehow have to save this. Once again, thinking back to the pedestal block entity, we've seen how this works with both the load and the save additional methods right here. So those two are basically what we need again. In this one, however, this time we also want to save a couple of other things, and that's going to look kind of like this. So that's going to be after the drops method. You can see we're going to save the inventory. However, we'll also save the progress and the max progress. Here, of course, once again, make sure that the keys for saving, right, for putting the integers and putting the NBT in here is the same as when you read them out. Those always have to match. Otherwise, you will, well, I mean, you're going to get issues and it's not going to properly work. Right, so far, none of this has been new. I think the newest thing here has been the container data. I will gladly say, let's say, admit that that is a little bit crazy, but, you know, hopefully still understandable. And then we get to some, well, sort of some custom things, quote unquote. First of all, obviously, the get display name is super freaking simple. This is just going to be a translatable text, and this is going to be block.tutorialmod.grove_chamber. I'm just going to use the same key over here, the same translation key as the grove chamber block, because that's just going to be the same name. And of course, our menu, well, we don't have that yet, so we're going to make a deliberate error over here once again to just remind us that we have to still fill this in. And before we do the logic, we then go back to the block class where we can simply import the grove chamber block entity, fixing both the drops method as well as the method for opening the inventory. Then in the new block entity method, we can make a new grove chamber block entity, passing in ppos, passing in pstate, and that is also done. And then the final thing to do is right here in the tick method, right, the get ticker method. This is where we want to hover over the tick method and create it inside of our grove chamber block entity. And there we have it. This is our tick method. I'm just going to move this above the synchronization methods because I always want them at the bottom. This is just a formatting thing, but it doesn't matter. You know, you could have them anywhere you want. I just personally like to have this so that I know roughly where I'm at. Now, in the tick method, like I said, this is the method that gets called once every tick or 20 times a second. And the idea is that here we can now do all sorts of things, and here is where our logic lies. Now, when it comes to the logic that I'm going to show you, this is where we sort of, where the world is our oyster in a sense, because this is where you get to just use your programming in whatever way you want, right? So you can check for a recipe, you can change blocks above this block if certain things happen. You can do all sorts of things in this tick method. You have access to the level, you have access to the block position of this particular block entity and the block state. And with those three things, you can do almost anything you want. And that's the cool thing. In the tick method, you can basically do whatever you so choose to do. And I highly recommend you also check out when you go to the block entity over here, you click on this, press Ctrl H to bring up the hierarchy over here. And then you can take a look at, for example, the vault block or the conduit block or the comparator block. There's a couple of them that are quite interesting. Now, I think one of the most important or most interesting ones is the base container block entity, and then the abstract furnace block entity, because this one, you can see, first of all, it also has some container data. Very interesting. it also, if you actually scroll down a little bit, has a tick method. This is called server tick right here, but it's the same idea. This is a little more complicated than it should be, but the idea still stands. Highly recommended to check those out. You can also check out block entities of other mods on GitHub. I also highly recommend that you do that, although sometimes they have some strange inheritance structure because it makes it, when you're working with a mod, it makes it way easier to work with a mod. However, it makes it way harder to read for someone just coming into it. But, so there's always, everything is a trade-off, basically. Regardless of all of this, though, that is the idea, the tick method. I'm going to walk you through the logic by just writing methods that don't exist yet, and hopefully you will understand the logic, and then we're going to implement those methods. Right now, we don't even need to know how to implement them. This is one way or one sort of paradigm that you can use in programming, where you just write out everything, how everything is supposed to work in terms of the logic, if the logic isn't too complicated, and then you worry about the implementation in a little bit. So that's exactly what we're going to do. So we're going to say if has a recipe. So once again, this is a method that doesn't exist yet because we haven't created it yet. We're going to create this in a second. The question is, okay, do we have a recipe or not? And that's the first question. I think that is a valid question, right? So the idea is that our input slot does have an item inside of it that basically can be turned into a different item by our growth chamber. That's the idea, and that's the question right here. But once again, we're not worrying about the implementation just yet. That is the only question we're asking, right? When I say we're asking a question, that's sort of an if statement, right? An if statement, you can think about this as asking a question, right? Do we have a recipe? Yes, then we are in here. If it's not the case, then else, right? Then we do something else. And something else we do, we're just going to do this immediately. We're going to reset the progress over here. That's the else over here. And that's the entire else statement over here. So if we don't have a recipe, we're always just resetting the progress. However, if we do have a recipe, then it gets interesting. Because now we want to start progressing or, start crafting, right? So what we're going to do is we're going to increase the crafting progress because right now we're starting to craft, right? That's totally fine. Here, we also want to call the set changed method with the level, block pause, and block state. So we can simply basically block pause and the block state. There we go. This just helps with synchronization again, and that's fine. Now, as we're increasing the progress, at some point, we have finished the progress, right? At some point, the crafting is finished. How can we get this? Well, we're just going to say if has crafting finished, right? That's all we're asking over here. And if that is the case, then what do we want to do? Well, we want to craft the item, right? Craft item, easy enough. And we also want to reset the progress again so that the crafting progress can happen again, right? So that it can start at 0, let's say, and it can continue again. And that's the entire logic of our custom block entity. That's all we have over here, and I'm telling you the reason why it's so interesting and useful to have this logic set up first and then implement it is that you're going to see this in the next tutorial when we're going to add the all of the structure around the recipe. Changing this structure is super freaking simple because we simply need to change a couple of methods and that's it. And it's going to be just amazingly adaptive, basically, if you want to change anything, right? Because has recipe, you don't know how it looks like right now. You just need to basically put in a Boolean. You can do whatever you want in theory, right? That's the beauty of it, and that's basically the idea. And we're just going to start with the has recipe method. I think that's fine. So we're going to go in here and we'll see. Now, when it comes to the recipe, like I said, we're going to hard code it right now. So we're going to have an item stack. This is going to be our input. This is going to be like I said, an input that is determined right now. So we're going to say this is actually, let's just going to be an item. So this is going to be an item input, right? So just so that we know which item we want to input. And in this case, let's just say, for the sake of argument, mod items raw alexandrite.get, right? So we can put in a raw alexandrite and we're going to get out an item stack. So this is the actual item stack over here that we're going to get out. And that is just going to be a new item stack, mod items dot alexandrite.get. There you go. So this is going to be our input and this is going to be our output. And now we need to ask the question, okay, do we have a recipe? Well, now you might say, I don't know what to ask here, right, as a question. Well, let's first of all think about this. We have an inventory and we have a slot. Do we have an raw alexandrite in the slot? I think that is the first question that's valid, right? So item handler dot get stack and slot input slot. You can see very much easier to read than 0 input slot dot is. And if this is the input, then we have a recipe. Now that is totally fine. That is awesome. And I would say that is amazing. And we could, in theory, proceed. However, we have to be a little bit cleverer than this because now let's think about this. we have an output slot as well, and we just take this output and we put it into the output slot, disregarding whatever's in there. Well, wait a second. If our output slot is empty, that is totally fine. Then we can output it, like we can put this out. Or if there already is an alexandrite in there, we can add to it. That's absolutely correct. However, what if there's 64 alexandrite already in there, and then we would try to add another one? That doesn't work. So we need to ask a couple more questions. So the next question here is, we're just going to append this with an AND operator, is can insert item into output slot, right? And I'm going to pass in the output over here. And another question is, can insert amount into output slot, right? Because we also have to check whether or not that's the case. Now here we're going to actually pass in the count over here. So the count of the output, in this case it is 1, but it could also be, 12, right? Maybe we're going to add 12 alexandrite per raw alexandrite. You don't know that, right? That's a thing. That is why we're going to try to make this as quote-unquote generic as possible, right? As general as possible. And we're going to see both of these methods. I'm just going to copy those over. Once again, those are self-made, let's say. And I will explain the logic over here. The can insert item into output slot very straightforwardly simply gets you the output slot. And it says if it's empty or if the item is the same as the output item. So if it's an empty slot, then we can insert whatever we want. Or if the item that is already inside of the output slot is the same as the item we want to just craft, right? So if there's an alexandrite in the output slot, absolutely no worries, we can craft it. And if it's empty, then obviously we can craft it as well. When it comes to the output, it's a little more complicated because usually our output is 64, right? So obviously an alexandrite can stack to 64. However, that is not always the case. So what we're going to basically say is that if we want to get the max count of the item that is in there, if it's empty, right, so there's nothing in there, obviously we can put in 64, that's fine, we're good, right? So that's going to be the max count. However, let's say our output is a sign, and there's already a sign in there. Well, signs only stack to 16, if I recall correctly. But there's definitely at least a couple of items that only stack to 16. And if there's such a case, well, then it's obviously not empty, because that's already in the output slot, and we get that max stack size and put that to the max count. And the idea is that whatever is inside of the stack right now, right, whatever count that is, right, let's say there are, the max count right now is, let's say, 64. Okay, that's fine. And the question is if it's smaller or equal to the current count. So let's say we have now crafted 63 items, but now we want to craft 12 more, right? Like remember, once again, in the output that we're crafting 12 more. Well, wait a second, that does not work, right? Because 63 plus 12, that is definitely not bigger, or that is rather bigger than 64. So that does not work out. So this would be false. Ergo, we couldn't actually insert that amount into the output slot. So this just makes sure that all of that validation works. Now, there are different ways that you could, in theory, do this as well. I think that the item handler has some amount of sort of logic about this as well. But I always did it like this, and I think that it makes sense. Hopefully, this is logical, which is basically the most important thing in this case. Logical and understandable. But yeah, that is the first logic, has recipe, and now we go into actually doing something, and this doing is we're increasing the crafting progress. So let's hover over this one and create that method too. Now this one, you might say, oh man, how are we going to increase the crafting progress? Progress plus plus, that's it. It's super simple. Sometimes you get like sort of hung up and you're like, well, wait a second, that does kind of make sense, right? Because we have a progress integer over here. We start this at 0 and we're simply increasing it by 1 every tick. And that means that at some point, has crafting finished will get called. Now, what is this going to be? So this is going to return whether this.progress is bigger or equal to this.max progress. So we're going to count every tick. Progress is going to tick up 1 as long as we have a recipe, right? It's going to tick up 1 until it reaches 72 or above it, right? The above it is basically if there's ever a glitch or something like that, then don't just do an equals. That can only lead to issues down the line. Bigger or equal is fine, right? So if it ever reaches above it, then we're going to be okay. And the idea is that at that point, we have finished the crafting progress, right? And we can craft the item. And now here you might say, oh, crafting the item is probably going to be quite a thing, right? Well, not really. It's actually not that crazy, right? We once again want to think about the output over here, right? So we can actually get the output again, right? It's the same output in this case. And then we want to, well, extract an item from the input, and we want to simply set the output to the output. Okay, let's take a look. So item handler dot extract item. from slot input slot. And we're going to extract one of those, and we're going to say that this is not simulated, meaning that this will actually happen. We're actually going to remove one item from the input slot. Okay, fair enough. And then we want to then say, well, how about we set the stack and slot output slot to something different. Now here, I'm going to do a sort of a trick of the trade. We're going to make a new item stack instead of using the outputs item stack. There's a reason for this, because we want to make it from the same item that the output is. All right, that's fine. And the count of this is going to be whatever the count in the output slot already is. So we're going to get the current count of the items plus whatever the count of the output is. Basically meaning that if we have 18 Alexandrite in there and we want to add 2, then that's going to do it. And now there's 20 in there. That's literally all we're doing in this case. And that's crafting the item. That's it. Right now, the last thing is to reset the progress over here. Now this one, oh, this one's going to be a rough one, isn't it? Well, of course not. This.progress is equal to 0, and this.max progress is back to 72. Now this is obviously going to be our default max progress. We can check this again at the top over here. This is our max progress, 72. And of course, the reason why I reset this here as well is feasibly, you could make it so that, let's say, a custom recipe, right, depending on what the recipe is, actually takes different amounts of time. Of course, you could do this, and you would then just change the max progress. This is also the reason why we're sending the max progress in here with the container data, basically so that this is changeable as well. And crazily enough, that is the entire block entity class done, except of course here for the menu, and the logic here is in there, and that will work. Now, once again, this currently is not ideal because it is hard-coded. I do recommend once you're finished with this and it works and everything is fine, then jump to the next tutorial once it comes out to basically also add the recipe type. That is super important because that will allow you to actually read in JSON files and create custom JSON files and then have as many recipes as you want. And that is a superpower, I can tell you. But regardless of this though, the next step is the menu and the screen. Once again, we have seen the screen and the menu over here, so I will gloss over the parts that we've seen already, and I will be, then explaining the rest. So we're going to create both of those classes in the screen custom package. It's going to be the growth chamber screen, as well as the growth chamber menu, growth chamber menu. There we go. And let's take a look. We're going to start with the menu. And once again, there's a couple of things that will be copied over, actually quite a few things. So do double check the description down below. The GitHub repository is super important in this case because it's just a very complicated, or there's lots of code to write. So there you go. This will extend from the abstract container menu. We're going to implement the 2 methods, and then we'll not actually implement we'll not create the constructor because we're going to just copy that stuff over. Starting off with the 3 fields as well as the constructor over here. Don't mind the errors. That's totally normal. We're going to, fix those in just a second. We have the block entity that we need. We have a level and we have the container data. In the growth chamber menu constructor over here, we once again have the container ID, the inventory, INV, and the extra data as a friendly byte buff. And then we're calling this again, and this is the secondary constructor that's going to look kind of like this. So it is has a p container ID, an inventory, an entity, and then data. And you can see that is basically what we're passing in over here. And there we go. Inside of the secondary constructor, we're going to call the super call. We're going to say mod menu types dot pedestal, no pedestal menu not get, absolutely not, because we don't actually have this yet. So we're going to make this just a comma over here and say p container data. The first one will then be added once the mod menu is properly registered. We can then go on block entity. We can then go on this.block entity is equal to entity. We can say this.level is equal to inv.player.level. There we go. And finally, this.data is equal to data. The entity over here, because this is a normal block entity and not the growth chamber block entity, we also have to cast this. So we have to say entity.cast and then cast this to a growth chamber block entity. Now, the fact that we basically always know that the growth chamber menu will only ever be opened by the block entity that is associated with it. So we are good by basically doing this. We should have no issues there. We once again need the add player inventory and hotbar. Those are the 2 methods that we've seen previously in the pedestal menu as well that are basically going to add the inventory and the hotbar. Those are exactly the same and they work exactly the same as well. So there's nothing too crazy about this. They simply add the layout of the inventory as well as the hotbar. And then we get to the layout of our custom one. And that is, I mean, pretty much the same that we've seen previously as well. So we're going to this add slot, new slot item handler, passing in block entity.item handler so that it knows which inventory we should use. And then this is for index 0. It is 5434. And then we can simply duplicate this and change this for index 1. It is going to be at position 10434. And that is the 2 slots. But we're not done yet, because the last thing we need to do is super important, add data slots and then passing in the data over here. And the idea here is that this then allows you to properly synchronize the data, because once again, this is the container data that we've created in a block entity that basically has the progress and the max progress. And we'll see this in just a second, how this is used. But first of all, still valid method is once again exactly the same as we've seen in the pedestal menu, right? We call the still valid method, create a container level access, passing in the level, passing in the block entity get position, the player, and here very importantly that you choose the mod blocks.growth chamber. That is, this is the correct block. Otherwise, you will run into issues. And finally, my favorite method of them all is of course the freaking quick move stack method, which once again will just copy over here. Once again, super important, the TE inventory count, you have to make sure this is correct to exactly how many different slots you have in your custom menu. Super important that this is set properly, otherwise you also will run into issues. But if this is the case, then the 2 last methods that we're going to need is crafting method as well as the get scaled arrow progress method. Now those look kind of like this. You can see that we're using the container data. Now, when you think about this, what is crafting mean, right? What does this mean? Well, data get 0 is bigger than 0. What the frick does this even mean? Well, we think back, what is container data? Well, our container data over here is this. And if we get the 0, we get the progress. Wait a minute. Indeed, if the progress is bigger than 0, all of a sudden we are crafting. And this is exactly correct, right? And the same thing or a similar thing happens in the scaled arrow progress, where the arrow is 24 pixels of size, right? This is the width of it. And we're basically just making sure that we get a scaled version of it, right? So if we're 50% done, I want 12 pixels of the arrow to show up. And this calculation, this particular method does exactly that. And that is the menu almost entirely done. We just need to register this. So in the mod menu types over here, once again, I will duplicate it, but be vigilant over here. A menu type of growth chamber menu. This is going to be the growth _ chamber menu. Exactly. And the name here too, growth chamber name. That's very funny that I called this name instead of menu. I don't know why I did that, but that's okay. We can just change it. It shouldn't, I don't think it should matter. And then here, of course, this is the growth chamber menu. Absolutely fantastic. And that is that. That's registered. And then here it is as easy as saying mod menu types dot growth chamber menu dot get. And the menu class is done. Awesome. And finally, the last big class to add is the screen, which will of course extends from the abstract container screen class of type growth chamber menu. We'll hover over this to implement the render BG method. Hover over this again to create this constructor mashing super. And then here we need 2 resource locations. The one we know already is the GUI texture, which is under textures, GUI, growth chamber underscore, or growth underscore chamber underscore GUI.png. Let's just add this because why not? So this is going to be textures GUI. This is going to be under the directory of growth chamber, making sure we write this correctly. And then this is going to be the growth chamber GUI. I'm going to show you this. It is super freaking simple. It is simply this. We have an input slot and an output slot and the gray arrow right here. And of course, we also need, as you can see, the progress arrow. So this is the arrow progress. I'm going to copy this over as well. And those textures will also, of course, be available to you down below for download. And then let's see. So in the menu, we, of course, number 1, need the render method again with the render tooltip right here. That's quite important. Otherwise, we are not going to have any names for our items, which would be a little bit bad in this case. And then the standard stuff that we've seen previously in the render BG method. This is pGUI graphics, but that's okay. So you can see, right, the render system calls over here that we've seen in the pedestal screen as well. Then just the X and the Y. And then we're basically calling the blip method over here, drawing the GUI texture at X and Y with no offset, and there we go. So this is the drawing of the texture, but how do we get the render progress? Well, that looks kind of like this. It's a little more complicated, and I will try to explain the best I can. So we are going to draw the arrow texture, which is literally just this texture. All right, this is 24 pixels, as you can see, 24 by 16. So that is the texture width and the texture height. All right, that's awesome. Now we're drawing this at X73 and at Y35. Okay, so those are the coordinates where we're going to draw this. And that is on the chamber GUI. That would be exactly at this position. So we're going to go, this would be 73X and 35 down. So there's going to be 73 here and 35 down. So we're going to be around about here. And now here is what we're going to start drawing. And the drawing is going to be dependent on exactly this. We're going to always draw the height of 16 pixels. However, the width that we're going to draw is dependent on the scaled arrow progress. And that is what makes this basically slowly appear over time, right? And that is the whole idea. I highly recommend you check out the abstract container screen of the abstract furnace over here for some different examples, because there's actually the lit progress over here as well as the burn progress sprite. Highly recommended to check out those as well for some, let's say, inspiration there. Definitely recommended. And then we simply, in the render BG method, after the GUI texture, very important, we call the render progress arrow method, passing in the P GUI graphics, passing in the X, and passing in Y, and that's it. This will now also show the progress, which is, I'm telling you, that is so freaking cool. Right, the entire thing is now done. I mean, the entire thing, but the entire thing is basically done. In the block entity class, we can finally create our new menu. So a new Grove Chamber menu, passing in P container ID, passing in P player level, or player inventory rather, passing in this, and then passing in this .data. There we go. That is exactly what we need. The rest here is done. We can close this, we can close the screen, we can close this, we can close this, we can close this. And we want to go to the tutorial mod class all the way down over here to our on-client setup event, where we want to call menu screens.register mod menu types .grove chamber menu.get, and then this is the grove chamber screen : new. Finally, we also want a translation. I don't think I have to explain that one. And finally, we also actually want some data gen, because in this case, the state is just going to be a normal block with item. So we're simply going to get, whatever block with item we have over here, and we're going to get this. This is going to be the Grove Chamber. There we go. Also, don't forget to add the loot, otherwise it's not going to work. We actually also have to add the loot for the pedestal, because otherwise the data gen is not going to work. This is the Grove Chamber. And then the Grove Chamber, of course, also needs a texture, crazily enough, which will also be available to you down below. That is going to be not an issue at all. So this is going to be under textures, block Grove_chamber. And I believe, let me just think about this for just a second. I mean, it is an involved process, right? So we did go through a huge number of steps over here. I think we should be good to go. I believe that indeed this should work. So we will be able to set down the Grove Chamber in just a second. Then it will be able to open this particular GUI over here, this menu, and we will be able to place in a raw Alexandrite right here, and it's going to craft us a normal Alexandrite. That's the idea, that's the hope. So let's first of all run the data to generate the JSON files associated so that the Grove Chamber actually has a texture. And once that is done, then let's jump into the game and see if it works. Alright, fans, back in Minecraft. As you can see, the Grove Chamber has been successfully added to the game, and if I right click it, there we are. And if I take a raw Alexandrite, what do you think happens? Well, of course, it starts crafting, and when it reaches the end, we have an Alexandrite gem. Absolutely freaking fantastic, and it works exactly how we all programmed this. Now, of course, like I said, this is just the beginning, because now being able to also make, all sorts of other recipes with JSON files, basically also allowing other mods in theory to make, custom recipes for your custom block entity. That is the dream, and that is a custom crafting block entity added to Minecraft. Absolutely amazing. Now, more important than ever, all of the code is, as always, available to you down below in the description in the GitHub repository. I highly recommend you get this to work once, and then from there, you basically will start experimenting. Always experiment once it works, and then just go freaking wild, and then just see what you can come up with. But that's going to be it for this tutorial right here. Next time in this video, we'll also add a custom recipe type hope to see you there. So, yeah.